Hi guys, welcome back. Okay, so let's take a look at how we're going to construct a 1 minus alpha times 100% confidence interval for a population proportion. So suppose that a simple random sample of size n is taken from a population, then the confidence interval for P, the population proportion, is given by this. So the lower bound, okay, because there are lower bound and upper bound, right? So lower bound is given by, well, we're gonna start with P hat, which is the sample proportion, right? That's our point estimate. And we're going to subtract our margin of error, which is given by Z sub alpha over 2 times the square root of P hat times 1 minus P hat over n. Okay, and the upper bound is given by P hat. Once again, this is the sample proportion plus the margin of error, Z sub alpha over 2 times the square root of P hat times 1 minus P hat over n. So this part here, right here, notice that we're adding and subtracting the same thing, right? So this is our margin of error, E, margin of error, E. So this is really P hat minus the margin of error, and then the upper bound will be the P hat plus the margin of error, right? And of course, we have our assumptions, right? SRS, and the sampling is independent, so n is less than 0.05 times the population, and we have n times P hat times 1 minus P hat needs to be more than or equal to 10. So of course, our assumptions must be satisfied. And this Z sub alpha over 2, this is from the last video, okay? But if you look at this distribution here, right? So the middle part is 1 minus alpha, and the tail area is alpha. But since we have 2 tails, so the one of them is going to be alpha divided by 2. Alpha divided by 2. So the Z sub alpha over 2 is going to be this point right here. This is Z sub alpha over 2, right? Where the right area, area to the right of the Z score is alpha over 2. That's this guy right here, okay? Okay, one more thing to point out, standard error right here. So we're using P hat instead of P. Okay, that's because P is unknown and P hat is the best point estimate, right? The value of P hat is the best point estimate of P. So that's why we're using P hat. Okay, so again, the interpretation of our confidence interval. A 1 minus alpha times 100% confidence interval indicates that 1 minus alpha times 100% of all simple random samples of size n from a population with an unknown parameter will result in an interval that contains that parameter. So a margin of error is related to a few things. It is related to our level of confidence, right? So our level of confidence is 1 minus alpha. And we see that as the confidence increases, the interval gets bigger or it gets wider. Okay, that means that we're more confident since we have a larger target, right? So if our interval is wider, then we're going to be more confident that the parameter is there. And the interval gets wider, that means that the margin of error, the wiggle room, has to increase, right? Okay, so our margin of error is also dependent on our sample size n. Okay, we can see it in our formula right there, right here. So there's the n right here, right? So as the sample size increases, the margin of error decreases, right? Okay, and then it will give us a smaller interval. Okay, so again, it kind of goes back to the thing, a larger sample is always better, right? If we can maintain the same level of confidence and get a smaller interval, that's a good thing. And finally, our margin of error is dependent on our standard error. Okay, which is this part right here. Okay, right, so as the standard error increases, the margin of error is going to increase. Okay, and it will give us a wider interval. Okay, so more spread means more variability, right? And then that would give us a bigger or wider interval. Okay, so now let's talk about z sub alpha over 2 one more time, and then we're gonna talk about the steps, okay? So z sub alpha over 2, this is called the critical value. And z sub alpha over 2 is somewhere here, okay? Where the middle part is 1 minus alpha, which is the confidence level, and z sub alpha over 2 is the z-score, where the area to the right of the z-score is alpha over 2. And this is called critical value. So a critical value is the number on the borderline separating sample statistics that are significant from those that are not significant, right? So numbers that are on the right side of a z-score, these are significantly high values. And then there is one down here, this is z sub 1 minus alpha over 2. That will be, so if values on this side, then these are considered unusually low, right? Okay, so if the confidence level is 90%, right, which is right here, that says 90%, okay, then alpha is whatever is left over, right? So that's going to be 10%, that's alpha. Alpha divided by 2 will be 10 divided by 2, which is 5%. Okay, so z sub alpha over 2 will be, so this part is, this is 5%, right? Okay, so it's gonna be, we're gonna use inv norm function, and then the area is 0.95. Why? Because if the area to the right is 5%, and then area to the left would be 95%. Okay, inv norm again requires the area to the left. Okay, so area is 0.95, and the mu 0, sigma 1. Okay, so when you type that in your calculator, it's gonna give you 1.645. Okay, so that's the critical value if the confidence level is 90%. Now, if the confidence level is 95%, then alpha will be 5%, right? And alpha over 2 will be 2.5%. Okay, so the z sub alpha over 2 will be inv norm, and the area will be, so the 2.5 is on this side, right? So if this is 2.5%, then the left area will be 0.975. Okay, so when you type that in your calculator, again, mu is 0, sigma is 1, you should get 1.96. Okay, now I want you guys to try 98% and 99%. Okay, so what will be alpha and alpha over 2 if confidence level is 98% or 99%? And then try to figure it out, the z-score. All right, so go ahead and pause the video and then come back when you're done. Okay, so if the confidence level is 98%, alpha would be 2%. Okay, and alpha over 2 will be 1%. So for the inv norm, the area you type should be 0.99. Okay, 1%, you subtract that from 100%, so 0.99. So you should get the z-score with a critical value of 2.33. All right, and for 99%, alpha is 1% and alpha over 2 will be 0.5%, right? And you subtract 0.5% from 100%, which will give you 99.5%, which is 0.995 in decimal form, right? So when you find the critical value of that, you should get 2.576. All right. So these are some common, values of a confidence level, 90, 95, 98, 99%. Okay. So these are the common critical values that you're going to be using for Z. Okay, so we've learned a lot of stuff, haven't we? So this is what we're going to do. We're going to put everything that we have learned so far in this section into steps, okay? So that we can use these steps to construct a confidence interval from scratch. So there are 6 steps to construct a confidence interval of population proportion. So every time I ask you to make a confidence interval of a proportion, these are the 6 steps that you're going to be using. Okay, so this is going to be important. Okay, step 1, describe the parameter P. Since we are estimating population proportion P, okay, our parameter is going to be P. Now you're going to have to explain what we're exactly estimating. It might be something like proportion of vegans in California, or proportion of people who have bachelor's degree in the United States, something like that. All right, and step 2, you're gonna have to find the point estimate, which is given by P hat equals X over N, right? So that's the formula, okay? So that's the sample proportion. And then in step 3, you're going to check the assumptions, right? On SRS. And number 2, the sampled observations must be independent, right? Which means N is less than 5% of the population. And also, you're gonna compute N times P hat times 1 minus P hat. Then we're gonna see if that's greater than or equal to 10, right? This will check the normality of the distribution. All right, and then in step 4, we're going to compute the critical value Z sub alpha over 2. And we use the inv-norm function on our calculator to do that. All right, step 5, compute the lower and upper boundaries of confidence interval. So the lower boundary would be P hat minus Z sub alpha over 2 times the square root of P hat times 1 minus P hat over N. And we all know that this part right here, okay, this is the margin of error, right? So this will be margin of error, E. Okay, and then the upper bound, which is similar to the lower bound, but now we have a plus sign in between the point estimate and the margin of error. So P hat minus E is the lower bound, and then comma, P hat plus E, that's the upper bound. And that's number 5. Okay, and then the last step is very important, the interpretation of the result, right? Now here's a template for you so that you can actually use this to write down your interpretation, okay? And it goes like this. We are blank percent, so this blank, right? You're gonna put the level of confidence. And this will be given to you in the problem. So, whatever the level of confidence is, right? Let's say 90%, 95%, you're gonna put that here, okay? So we're 90%, I'm just gonna put 90% as an example, confident that. And then next part is going to be the parameter. So whatever the answer you put here in step 1, that's gonna be right here. Okay, whatever parameter you are estimating, you're gonna explain that here. So confident that blank is between blank and blank. So the lower bound is gonna be in the first blank, and the upper bound is gonna be in the second blank, right? And that's it, okay? So that's how you interpret it. We're 90% confident that, and you talk about the parameter and then say is between these two numbers, lower and upper bounds. All right, so let's do an example using these steps. Okay, an example. A research center poll of 1,500 randomly selected US adults showed that 1,275 of them know what Twitter is. Find the 90% confidence interval estimate of the population proportion of US adults who know what Twitter is. Then interpret the confidence interval. Okay, step 1, describe the population parameter of interest. Okay, so it says here clearly that they want you to find the 90% confidence interval estimate of the population proportion of adults who know what Twitter is, right? So the parameter is the proportion, right? The population proportion. So that's what you have to describe. Okay, so parameter is the population proportion P. Okay, so it's the population proportion of US adults who know what Twitter is. Okay, so that's step 1. Okay, step 2, find the best point estimate. Okay, so that's gonna be P hat, right? The sample proportion. So P hat is X over N. So N is the sample size. So that's gonna be 1,500 randomly selected US adults, right? Okay, and out of 1,500, 1,275 of them know what Twitter is. So when you divide that, you're gonna get 0.85. So 85% of the sample of 1,500 adults know Twitter. Okay, so that's P hat. Step 3, we're gonna check the assumptions. All right, so number 1, simple random sample. Yeah, we can say that. It says randomly selected US adults. So we can assume that that's a simple random sampling. Okay, so that checks. Number 2, is N, which is the sample size, less than or equal to the 5% of the entire population? Well, 1,500, right? 1,500 is a pretty small number as compared to the entire population of US adults. So yeah, we can safely say that this is true, right? Less than 5% of the entire population of the United States. Okay, number 3. Okay, so that's gonna be, you're gonna check N times P hat times 1 minus P hat. Let's see if this is more than or equal to 10. So N is 1,500, and we multiply that by 0.85 times 1 minus 0.85. Okay, so when you punch these numbers in your calculator, you're going to get 191.25, which is more than 10. Okay, so that checks. So that verifies the normality of the distribution. All right, so that's it for step 3. Step 4, find the critical value. Okay, that's Z sub alpha over 2, right? So, well, first we need to know what alpha is, right? So alpha, again, is the complement of the confidence level. So confidence level is 90%. So what's left over? 10%. That's alpha, right? So we divide that by 2 because we have 2 tails, right? So alpha over 2 is 5%. So we're gonna figure it out, the Z sub 0.05, right? So we use norm. Okay, and since we want the left area, so it's gonna be 0.95. Mu is 0, sigma is 1. Okay, so you're gonna get 1.645. All right, so that's the critical value. Step 5, find the lower and upper boundaries. Okay, so the lower boundary formula is p hat minus, so p hat is the point estimate, right? So p hat minus the critical value, which is z sub alpha over 2, times the standard error, which is the square root of p hat times 1 minus p hat over n. Okay, and remember, this part right here is the margin of error, right, from z to the end. Okay, and the upper boundary is going to be p hat plus the margin of error. Okay, so let's substitute the values that we know, right, into the formula. So p hat, that's 0.85. So 0.85 minus z sub alpha over 2, that's 1.645, times the square root of, once again, 0.85 times 1 minus 0.85 divided by the sample size, which is 1500. Okay, and then when you punch these numbers in your calculator, you're going to get 0.835. Okay, so that's the lower bound. Now the upper bound is 0.85 plus 1.645 times 0.85 times 1 minus 0.85 divided by 1500. Okay, and again, when you punch these numbers in your calculator, you're gonna get 0.865. Okay, so you can write your interval, okay, down here. So 0.835 comma, okay, and then the upper bound is 0.865. Okay, so here we go. All right, so that's step 5. Okay, step 6, interpret the confidence interval. Okay, so let's use the template that I gave you in the previous page. Okay, so we can say something like we are, and then you write down the level of confidence for this. So 90%, right? So we are 90% confident that, okay, and after that, you're going to copy the population parameter that you explained in step 1. Okay, so that's pretty handy, right? You have that already written down in step 1. So we're 90% confident that the population proportion of US adults who know Twitter is, then write down the lower and upper bounds between 0.835 and 0.865. Okay, now if you want to write lower and upper boundaries as a percentage, that's okay too. 83.5% and 86.5%. Okay, here we go. So that's it. All right. So once again, okay, so this 90% confident level, right? What that means is that if you were to create, let's say 100 different confidence intervals using 100 different point estimates, p hats, right? We are going to expect about 90% of them, so 90 intervals, will include the population parameter, which is population proportion of US adults who know Twitter, right? And the other 10 intervals will miss the population proportion, okay? All right, so that's it, right? So every time I ask you to find or construct the confidence interval estimate of the population proportion, okay, you're going to follow these 6 steps, okay? So let me show you how to find the lower and upper boundaries of confidence interval using our calculator. All right? Okay, so go ahead and take out your calculator. All right, so you're going to learn how to construct a confidence interval for population proportion P on your calculator. Okay, so I'm going to show you how to work it on the calculator in a second, but here are the steps. Okay, so first you're going to press Stat and highlight tests, and then you're going to select one prop Z int. Okay, so you're gonna go down to A, okay, and then you're gonna select one prop Z int, and then you're gonna press enter once you get there. All right, and you're going to enter the values of X and N, and then type the confidence level, whatever that might be, you know, 0.90 or 0.95. It depends on the problem. And then you're gonna highlight calculate, okay? And then you press enter. Okay, so let's take a look at the actual calculator. Okay, so first you're gonna press stat, and you're gonna use the right arrow to highlight tests, okay? And then you're gonna use the bottom arrow, okay? And you're gonna go to the next page. Okay, oh, I missed it, right here. A1 dash prop Z int. So this is the one you want. Okay, and then once you get there, go ahead and press enter. All right, so you see X here and N down here. So go ahead and type I'm gonna be using the information from the last example that we did. So the Twitter example. So I already put the information here, so you can go ahead and type the same information, right? So 1275, that's the value of X, and 1500, that's N, the sample size, okay? And the C level, that's the confidence level. So we're using 90%, so 0.9, okay? And that's pretty much it. So you're gonna go ahead and highlight, calculate, and press enter. There you go. Okay, so what you see here is the lower boundary, which is 0.835, right? If you round to 3 decimal places, and the upper boundary is 0.865, right? So which is the same answer that we got from the formula. Okay, so and then they also give you extra information here, p hat, which is the point estimate, 0.85, and also n. All right. So that's it for this video. I will see you in the next one. Bye guys.